Hey there, Mr. Sutton here, bringing you the AB Calculus 4-2 lesson on increasing and decreasing intervals. In this one, we will be determining where a function is increasing and decreasing, and as a real-life application, when a business is making and losing money. For our warm-up on this one, here's a question for you to ponder. How can we test to see if a function is increasing or decreasing at a single point? And then, along the same lines, where does a function change direction? So pause the video and think about this one. Now, you might think, well, I'm in a chapter called Applications of Derivatives, so there's probably a derivative involved somewhere. And you're right, there's actually something called the first derivative test for a function, which says that if the first derivative, f prime, is positive, greater than 0, the original function is increasing at that spot. Whereas if f prime is negative, then your original function is decreasing. Now, this is good as far as it goes, but, are we just going to test every single x value to see whether we're increasing or decreasing? No. There's only certain places that we could change from one of these to the other. Those would be places where the derivative is either 0 or undefined, critical values. So our strategy then is going to be to find these critical values and just do sign analysis around those. With the first derivative test in mind, pause the video and see how far you can get listing out intervals where this function is increasing and decreasing. Alright, so to use the first derivative test, well, you need a derivative, so let's take that. That'll be 3x squared minus 6x. And again, we need to find critical values for this thing because that's the only places f prime could change sign. So we're going to set this equal to 0. I can factor a 3 out of this, so that'll leave me with x squared minus 2. And if I solve for x, adding 2, square rooting, I see that I have critical values at plus or minus radical 2. Now, there's no closed interval like there was when we were doing extreme value theorem. So on these problems, we have to consider all the critical values no matter what. So we're going to do some sign analysis now around negative and positive root 2. So here's my number line. And by the way, when you're doing sign analysis with these sign charts, you should always label them with the function you're doing the analysis on. So I'm going to stick an f prime here because that's what I'm actually testing out. So I've got negative radical 2, positive radical 2, and I'm just going to plug in an x value from each of these three intervals into f prime to see if it's positive or negative. So plugging in something less than negative radical 2, well, let me just plug in negative 2. This would be like negative radical 4. And if I plug that in here, I see that, let's see here, that's going to be something bigger than 2 minus 2, so that's going to come out positive. Next, a number between negative and positive root 2. Well, 0 is my favorite number to plug in. That's just 0 minus 2, which comes out negative, and this 3 is positive out here, so negative overall. And then bigger than 2, radical 2, let's plug in positive 2. So that's 4 minus 2 comes out positive. Now I just have to figure out, where am I increasing, where am I decreasing? I always do the increasing first just to be consistent. So I notice that my f prime is positive over here and over here. So I'm going to write f is increasing on the interval from negative infinity to negative radical 2, union radical 2 to positive infinity. And next, for my decreasing, that's where f prime is negative. So I can say f is decreasing on the interval from negative radical 2 to radical 2. Now notice here, I used these open parentheses, which is totally legal. Are you really increasing or decreasing at the spot where the derivative is 0? I would argue you're not. Having said that, the AP exam sometimes includes these critical values where the function is defined, at least, in the intervals. So this parentheses here could have been a bracket. This one also, if you saw this on a multiple choice on the actual AP exam. And sometimes it isn't. It kind of changes from year to year. Here's another one for you to try out. Pause the video and give this one a whack. Alright, so to make my derivative a little easier to take, I'm going to make this x to the negative 2, whose derivative is negative 2x to the negative third. And to make it easier to find critical values, I'll just put this in fraction form. This is negative 2 over x cubed. Now, solving for critical values, since this does not have a variable in the numerator, there's no way this is ever going to be able to equal 0. However, since we have variables in the denominator, our derivative is going to be undefined, does not exist at x equals 0. So that actually counts as a critical value that we can test around. All right, let's go ahead then and put that on our f prime line. So there's 0, and I'll test a number to the left of it, like -1. If I plug -1 in here, well, I have an odd exponent, so that makes it negative initially, but the negative out here makes it positive. And then if I plug in +1, this just comes out to -2, so negative. So then I can say that I'm increasing on the interval from -infinity to 0, and decreasing on the interval from 0 to +infinity. Now, a few other notes while we're here. For one thing, notice that I'm still, just like I did on the last example, writing out f increasing. I'm not just saying increasing without telling you which function is increasing. Also, note that on this one, I could not actually include 0 in either of these intervals because the original function is undefined at x equals 0. So you can't say that it's part of an increasing or decreasing interval.
For our last problem, we're going to combine a real-life problem with a little calculator fun. So we have the balance of a company's bank account X months after the beginning of the month being modeled by this f of x function down here. So we have some kind of quadratic inside a trig function. That should be fun. We want to know when the company is making money and losing money in the first 2 months. So as a kind of numerical math problem, we're basically asking, where is f increasing, where is f decreasing over this interval from 0 to 2? Now, when you're doing this problem, you're going to find that it's going to be a little bit tricky to solve for critical values algebraically and also to do sign analysis with this type of a function. So it is also possible, if you're allowed to use a calculator, you can do sign analysis on the grapher itself after you write out f prime and solve for the critical values. In fact, you can also use the grapher to solve for the critical values, which we've already kind of done. So pause the video and kind of using this hint, see if you can figure out where our profit and loss is for this company. All right, let's see how you did. So first we need to write out f prime. So that's going to be using a chain rule. So we're going to have sine of something, the derivative of that, which is going to be the cosine of the something. So cosine of 1.5 x squared, times we need the derivative of the something. Derivative of 1.5 x squared is going to be 3x, just using our power rule. So this is what we're going to see if we can figure out, where it equals 0 on the graphing calculator. So let's go to Desmos, and let me write out this function. So we've got, I'm just going to call this g. So g of x equals cosine 1.5 x squared times 3x. No need to simplify it. And wow, that's pretty wild looking. So we want to figure out what are the critical values and also where is this thing above or below the x-axis, positive or negative. Now the good news is we only need the interval from 0 to 2. So let's go to my little wrench here and adjust my x window. I'm going to make this go from, let me make it a little less than 0, so negative like 0.2. And I'll make it go to 2.3. Always good to go a little further than the window you need. All right, so here's what we're looking at. We've got a critical value at 0, which we don't need to worry about because that's one of the endpoints. We have a critical value at 1.023, and we have another critical value at 1.772. We have another critical value all the way over here, but that's past 2, so we don't really care about that so much. So here's what I just graphed out, and I see that I've got those critical values, again, 1.023 and 1.772. I'm going to call those A for this first one and B for this second one, just so I don't have to keep rewriting that number. And now I'm going to do a little sign analysis on here. So again, we're just trying to figure out where this derivative is positive or negative, and I can just look at the graph to see that. I see that we are positive above the x-axis between 0 and point A, and we are below the x-axis negative between A and B. And then after B, and until we get to 2 at least, we're positive again. We're above the x-axis. So just writing out my answer, I can say that f is increasing on the interval from 0 to A, again because f prime is positive there, and also on the interval from B to 2. And then f is going to be decreasing from And by the way, this increasing part, this is where our company is getting profit. And then F is decreasing from A to B. Nice to just be able to write A and B. That's where our loss is happening. So at this point, our time has decreased to nearly zero. Hopefully your knowledge has been increasing this whole time, though. Until next time, Mr. Sutton signing off.